of these is a perfect square? 9. Okay, so when we're simplifying this, I can break this down because I can simplify. What's the square root of 9? 3. Now, is the square root of 7 a perfect square? Can it be divided by another perfect square? No. So it just stays the square root of 7. So what they're showing you here is that when you have a number under the radical sign, you are looking to try to divide it by a perfect square so that you can simplify it. And we'll do some more examples here. So look at the square root of 150. Think about your perfect squares. Is there a perfect square that divides into 150? 25, right? Okay, so I know for sure that I could rewrite this as the square root of 25 times what? What times 25 equals 150? 6, right? Okay, so I know that I can rewrite it like that. Now, once you get it to that point, you're just going to give each number its own separate radical sign. This is the same thing as this. All right? Now, can I simplify the square root of 25? Is that a perfect square? What is it? 5. Can I simplify the square root of 6? Can it be divided by a perfect square? No. So it just stays the square root of 6. So this is your answer. This is the simplified answer. Yes?
So we're not finding the 8.
No, we're not finding the exact answer. So it's just the simplified answer. Now, what's the difference between example 2 and example 1? We have a variable, okay? So again, I would say the first thing that we want to do is we want to separate 18. Okay, we want to think about the perfect squares, and is there a perfect square that divides into 18? 9, right? So 9 times what? 2, and then we have times t squared. So I'm just kind of factoring. It's just like, remember when we did prime factorization? It's kind of like that, except instead of factoring by prime numbers, we're factoring by perfect square numbers. Now, I'm going to rewrite this, and I'm going to give each term its own radical sign. So I'm going to give the square root of 9 a radical sign, the square root of 2 a radical sign, and the square root of t squared a radical sign. Now, can I simplify the square root of 9?
Yes.
What is it? 3. So now I have 3 times the square root of 2. Now look at the square root of t squared. What's the square root of t squared going to be? Just t. So times t. Now, it's customary to write this in a little bit different order. Here's how it's customary to write. You always put the simplified version of what you're trying to get at the end. So I'm going to rewrite it like this. 3 times t times the square root of 2. So that's the customary way, or the standard way to write it. And you can do that because, remember, we started talking about this way back in 6th grade, that you can rearrange the order which you're multiplying, but it doesn't change the answer. So I think the next page gives us some practice. Okay, so let's go through those. Now, think about 75. 75 is divisible by quite a few different numbers. If I was to tell you to write all the factors of 75, one of those factors is a perfect square. 25. you used 8 and 7, but the square root of 8 is not a perfect square. But 4 times 2 is 8, but that's not a perfect square. It has to be 4 times 4, or 2 times 2. Yeah. So I mean, if you got it to this point, then you would have to rewrite it as the square root of 4 times the square root of 2, and then you would have had the square root of 2 times the square root of 7, which is still the square root of 14, but it would still be 2 times the square root of 14. So yeah, make sure you're not multiplying it by 2, that you're multiplying it by itself. Okay, so that's kind of the difference between that and factoring. Okay, so next is what happens when it's a fraction. The easiest way to do this is to see what they have done here in the example. The radical sign is over the whole fraction. We're going to rewrite it to where both the numerator and the denominator have their own radical sign. And then we're going to do what we've been doing. So for example, the square root of 17 over 25. We're just going to rewrite it where each the numerator and the denominator have their own radical sign. Now we're going to look at it. Can either one of those be simplified? The square root of 25. Now can the square root of 17 be simplified? No. So it's going to stay the square root of 17, but the square root of 25 is what? 5. And then that's your answer. Okay. So again here, well, let's work through these real fast. We're just going to rewrite it like this. The square root of 5 over the square root of 9. Can the square root of 5 be simplified? No. So it's going to stay the square root of 5. What about the square root of 9? What is it? 3. And that's as simplified as I can get it. And that's my answer. Now, rewrite here the square root of 21 over the square root of 64. Now look at 21. We know that 21 is not a perfect square, but can it be divided by a perfect square? Which one? 7 times 7 is 49. No, there is no perfect square. But you would want to check that. You would want to check it to see if you could simplify it. Okay, but it can't be. So it's going to stay the square root of 21. What about the square root of 64? 8. It's 8. And so there's my simplified answer. Okay, now on this one, we've got the square root of 16z over the square root of 49. Now, why is this one a little bit different? Okay, it has a variable. So here, until you get the hang of it, here's what I'm going to suggest you do. For each term, rewrite square root of 16 times the square root of 2, either one of these. Okay? I would prefer to write this one, because you would have to simplify this one down even more, right?
Did you write?
Okay, because I divided 32 by 16 and 2 here. Because I can't simplify this, but I can this one. But if you look at this, I could rewrite 8 as the square root of 4 times the square root of 2 also. So you're always looking for the biggest perfect square factor, which in this case is here. Now, the rest of it is the square root of y squared, and then what's my denominator? Or the square root of 81. So now from here, I'm going to go through, I'm going to bring it back up here. What's the square root of 16? Can I simplify the square root of 2? No. Can I simplify the square root of y squared? What is it? Y. Now, what's the square root of 81? 9. Is that how I would write it? I would rewrite it as 4y times the square root of 2 over 9. And that's my most simplified version. Okay. And I'm actually, let's skip number 4, because I just kind of want you to get familiar with
I'm so impressed. Y'all are learning so much. You're going to be so ready for what comes later. I'm so excited.
thank you for visiting.
Loved it. Bye.
Bye. Let me see practice A. Example 4 is just an application problem. I don't want to overwhelm you with that right now. I just kind of want you to get the standard practice. You know what I mean? Okay? Because you'll see this again. You will see this again in an application form. But right now, before giving you the application, I just want you to practice the skill. So